Hello, dear colleagues. My name is Filip Sutanov, and I'm going to present a paper with title Connectivity in Sensor Networks. The objective that I'm going to analyze the problem in wireless sensor network related to various factors leading to disruption of the network connectivity, defining the concept of the connectivity in the wireless sensor networks, investigation of the connectivity in the sensor network with mesh topology, and formulation of conclusions about the factors influencing the life cycle of the sensor networks defined by the network connectivity. The outlines of the paper is introduction, connectivity of the sensor networks, is split in the connectivity in the sensor network depending on the density of the sensors in the area, the network connectivity feature of the different network paths, and the connectivity is defined by the probability and possibility use of specific antennas. Mesh organization in the network, that is, I'm going to talk about the devices building sensor networks, main subsystems in one sensor unit, and the architecture of the mesh networks. And the last is simulation study, connectivity of the sensor networks with mesh organization. Short introduction is that we know that the technological basis to establish Internet of Things is the wireless sensor networks. The ability of that kind of networks is very wide, used to build various systems like surveillance, security, emergency, military, and etc. That devices are cheap and their quick installation makes it arise the interest in the study of the networks with using those capabilities. The connection between the sensors in the networks determines the reliability of communication between them in the different industrial systems and plays essential roles in the data security. To decrease the risk of compromising the communication between the devices and to increase the security, manufacture of Internet of Things devices traditionally rely on the industry proven communication standards like Zigbee, Profibus, Modbus, and etc. Connectivity of the sensor networks and the characteristic of that communication, quality of work of networks, and connected to other characteristics of the networks and life expectancy. The wireless sensor network lifespan is taken as the time interval from the commissioning of the network to the moment of depletion of the energy resources of the network devices with the safe power supply. Network connectivity has characterized the network as the whole, not the properties of each individual element. A sensor network is considered connected when there is at least one path between each devices, and the connectivity depends on the availability of possible paths, the density of the sensors in the sensor area, and the use of the directional or intelligence antenna integrated in the devices. The mesh organization is that kind of network is a building from a following type of components and devices: mesh gateway, sensor or router, or mesh clients are like end device, and mesh access points. Mesh organization from the sensor, and on the slide I'm showing the sensor unit and the components, which is a couple subsystems, which includes the processor, the interface module, the sensors, and actually the subsystems defines the field of the application of the sensor, depending is an analog or a digital sensors. The communications is essential as well, because each sensor needs the interface to communicate with the rest of the units in the network. The wireless sensor network can be defined as a network of the devices that transmit information collected from the controller field area in the wireless real connections. and the connected data is forwarded through multiple nodes, and the gateway is responsible to sending that collected data to a remote database servers for a further proceeding, or storing the data from other networks, which is showing on that figure. The network model and the problem formulation, I use a model of standard heterogeneous multi-hop wireless sensor networks containing an heterogeneous sensors node with integrated antenna that can transmit its the coverage area, and they are allocated in two-dimensional terrain. Wireless sensor networks is described like graph G, which is equal to V and E, where the V is the sensor nodes and the E is the set of the transmission connection, called edges between the pairs of the nodes. Actually, we using the program code with the MATLAB has been developed for the simulation studies of the connectivity in the sensor network, depending on the number of the sensors, the radio communication range, and the size of the sensor field, depending on the network topology. On that slide, I'm on the two figures showing the simulation study result depending on the nodes, their numbers, the communication, radio range, and the size of the sensor fields. Each figure, each square shows actually the average result of the set of simulations performing with the changing area of the sensor fields, and the changing start from 250 meters by 250 meters, and the number of the nodes from 50 to 300 with the step of 50 nodes, and the radio communication range from 50 to 100 meters with the step of 10. The figure on the left is showing the connectivity, which is increasing the radio communication range and the number of nodes, regardless of the size of the sensor fields. And the figure on the right is establish the connection between the nodes numbering and the relations to the radio communication range and the parameters of the sensor field. It seems that there is excess of the connections at the big number of the nodes with the large radio communication range. On the next slide is showing on the left the excess of the connection makes the network more expensive. It requires special algorithms for the communication to improve that efficiency of the energy of the networks. The likelihood of problems with the transmitted data and the security, the dependence of the network connections on the radio communication range shows that the increasing number of the connections leading to the excess of the connections. And the last figure is the summary, actually the concluding simulations, depending on the radio communication range, the area, and the number of the nodes. The conclusions, the hierarchical presence and examining the characteristic of the sensor networks with a mesh topology that refers the network's ability to determine connection between the network elements of the network with the geometric borders of the network field in real time at a certain battery electricity level of the sensors. The simulation object of the survey is wireless sensor networks considering of the sensor devices controlling the physical space of a certain dimension and the coordinator located in the center in the sensor field. The obtained results identified the interdependence of the network parameters in the geographic dimension and the area of the sensor field, the model of the distribution of the networks in the field in the topology mesh, and different radio communication range. it has been found that the desire to ensure network connectivity leads to a redundancy of connections, which in turn increasing the network cost and requires a special communication protocol to improve the energy efficiency of the network and the probability of the security issues. Thank you for your attention. That is my contact if anyone wants to ask some questions.